Hello friends, welcome back to the video. What's up? What's going on? In this video, let us discuss about some of the papers which are needed for the machine learning beginners. So these are all the basics concepts you need to just refer with before going or before jumping to any of the machine learning algorithms. So if you are a beginner, then this video is going to help for you. The soft copy of this paper have been just given in a description. You can just download that paper from that below link. This is the paper. So it is a simple way to prevent neural networks from overfitting. So overfitting is a problem which is most common problem which are going to be just occur in a neural networks. So overfitting is like it works efficiently only for training data set. So the efficiency will be 100%. But whenever you are going for and testing, the efficiency will be considerably reduced to 40%. So in order to understand what is overfitting in detail, you can just go for this video. So if you are having too many of parameters, here parameters means the features. If you are having too many of parameters, then deep learning is the only thing which is going to provide you a more effective results as compared to classifier based method. A very basic paper on neural network, a simple way to prevent neural networks from overfitting. So in order to avoid overfitting and to improve the predictions from a various neural networks, dropout is used. So what is dropout in a deep neural network? Based on the random probability, some of the layers have been dropped temporarily. So let's check it out. What is dropout? What you are seeing at the left hand side, that is the figure A, it is a standard neural network. Here all the neurons have been tightly bound to each other. So every neurons have been connected to every other neurons in the layer. So this is the standard neural network. So here there is a chances of overfitting and there is a high risk of having a wrong predictions due to an over complexity. So in order to avoid these issues, we are going to select a random predictions or a random layers based on the random probabilities, and these layers have been temporarily removed from the network, and this network is called as a dropout network. So instead of having these many complications in between the layers, we have been just removed some of the layers output temporarily, and that base network is called as a dropout neural network. So this is the core part of a dropout. Let us see what is the let's see how it is going to be just modulated. This is a normal network and this is a dropout network. So then before going to that, we can understand some of the terminologies which have been used in this principle. So Z is a number of an input vector, and L stands for different layers of a neural network, W stands for an weights, and B stands for a biases, and Y stands for intermediate output. So this Y is a previous output of a neural network, and this Yi is a next version of our output layers. Next version of output layer is equal to the function of a Zi. Zi is a weights multiplied with the output of the previous one, and it has been added with the bias values. So here function is activation function. So that is given by 1 divided by 1 plus e raised to minus x. It states that it is a ReLU function. So it has been modulated in this figure. So Zi is just a multiplication of Wi into Yi, that is Y is a previous output, and it has been added with the weights of a previous one. So in order to obtain a Zi, Wi into Yi is multiplied and added by Bi. So after this, we are applying a function, activation function, in order to get the output of the next version or output of a next layer. So this is a normal standard network. So here comes a dropout network. So it is being given by this respective formulas. So R is a random probability. So the only change between the standard networks Under dropout networks is adding a normal probability in order to choose which layer is going to work sufficiently. So this is the equation. So RL is going to store the random probabilities. This RL will be multiplied by the previous output and it has been obtained with a Y dash L. So Zi has been obtained by just multiplying Y dash L with weights and added with biases. These two steps are same as compared to a standard layer. Only the addition here is random probability is going to be added with the output of a previous layer. That is what it has been shown in this figure. So here we are having a Zi which have been multiplied by the previous version of output y3 of 5. So y3 is going to be y dash of 3 is going to be obtained by multiplying previous output with a random probability, and it has been added with a biasing. So after obtaining all the values at a Zi, the function is applied, the activation function that is called as a ReLU. In order to understand the activation functions, you can watch this video. So after applying activation functions, we are going to obtain the output for the current layer. So like this, L+1 indicates that it is the next version. So these are all the equations. So this is all about the model principle. So one of the serious problem in machine learning is overfitting. So in large networks, overfitting is one of the major issues, and it is too much slow if you are going for a larger number of data sets. So in order to make this compactable, we need to have a deal between an overfitting and an prediction. In large networks, overfitting is one of the major issues. So if you are unable to recognize this overfitting, it will definitely harm the efficiency of a system during test time. The technique which have been provided in this paper is, in order to avoid overfitting, one of the suggestions which have been provided in this paper is dropout. So dropout is one of the technique which is used to avoid the overfitting. So what it actually says that it is going to randomly drop some intermediate layers from a neural network during training phase. So you should note here randomly dropping some of the units. So that is called as a dropout technique. So this testing, the network are going to be just converted into a thinned networks, and during a test time all the average predicted values of a single network have been formed to an thinned networks which are having a very smaller weights. So that is what which have been just given here. So it is an adoption of a dropout technique in order to reduce the fitting. So this is one of the solution. So in this paper they are going to just provide you information about how exactly the algorithm have been worked by employing dropout in their neural networks. So there is a comparison with dropout and without dropout, and they have been taken a various data sets. It can be an cipher 10, cipher 100, or it can be any sorts of biotechnical applications. So these are some sorts of things which have been just discussed in this respective paper. Set is less than 500 and all, this neural network doesn't work considerably. So that is what this para is going to tell you. With a limited data training set, so if you are unable to make a more efficient models. Jump to this, what is dropout network and what is the standard neural network. So what are all you are seeing at the left hand side, that is this side. So this is a standard neural network where you can just see all the neurons have been densely connected. So this configuration is called as an fully densely connected network. So this is the thing where all the neurons have been connected to each other. You can just observe here, all the neurons are going to be just connected to each other. So that is called as an fully densely connected network. So during this condition, there is a chances of having an confusion for your respective classifiers or neural networks. So the confusion is like let us consider an example. If you are going to make a difference between a tiger and a cat, so these data sets are going to be just collected at a different age group, different position of a tiger and a cat. But one of the confusion here is both tiger and cat will be almost same during the age of a childhood. These confusing matrices are going to be just removed from a data set temporarily, and they are being coming up with a newer neural network by dropping this layers, and they have been just reduce the number of connectivity between the layers. So this will definitely enhance the performance because the complexity has been considerably reduced. You can just see how much complex the layers have been just bounded here, but here the intermediate layers have been dropped out. So this is one of the technique, dropping out the layers randomly based on the confusing data sets. Standard neural network, and the right hand side is a dropout neural network. We believes that by combining the several models we can enhance the performance of the machine learning. So it can be somewhat true, but it is going to make you a expensive algorithm, because for each algorithm you will be having a different parameters. In order to search for different parameters, you need to undergo and several other changes. In order to do all these things, you need too much of cost. So it is going to tell you that if you are going to combine several things, it is going to make you an cost. It is not going to make you an cost effective. So that is what this paragraph is going to tell you. And this paragraph is going to tell you about the dropout technique, what I have been already explained you, dropping out of the some of the confusing data sets, out of the layers randomly based on the probability. So it prevents the overfitting, and also it is going to enhance the, which is randomly removing the layers based on the probability. It is going to avoid the overfitting. So dropping out means temporarily removing it from the network along with all the incoming and outgoing connections of it. So temporarily we are just removing those networks from a layers. So this is like removing this temporarily lines, this lines temporarily, and construct a new network by dropping some of the layers. So this is called as a dropout thing. This is a dropout training and testing phase. So after applying a neural network of having a dropout thing, so here is a single neuron. So for the single neuron you will be having some set of features or a set of inputs. Based on the probability we are going to select some things. So those things, based on those probability, we are going to assign the weights and we are going to propagate to a next layer. So this is called as a training phase. So in a testing phase, so that is what which have been told here, at a testing time, averaging the prediction of a exponentially available of your data. So here we are going to have this probability into weight. So it is going to be just multiplied. So all this probability which have been taken in a training phase is going to be just multiplied by the weights at a testing time. So that is what this paragraph is going to tell you. So multiplied by a probability with a weight. So that is what it has been shown here. So that is like this paragraph is going to tell you how exactly this model is going to be just designed. So this paragraph is going to tell you how the layers are going to be just designed. The first point is consider the L layers. You can just have the L layers, any number of layers. So these are all the n number of layers starting from 1 and it is ending at the nth value. So this is what this L hidden layers. So these are all the L hidden layers. So that L is the combination of 1 to small l's. So different layers. So that is the very first one. Too easy. So the first we need to select the number of hidden layers. So the number of hidden layers is considered as L. So it can be ranging from 1 to n. So this Y is the L hidden layers. So it can be number of hidden layers. So L is a subset of starting from 1 and it reaches some L value. So you can have some number of hidden layers. So next one is ZL. So ZL is a multiplication of weights of our respective layers which have been multiplied with a going to hold you the products of weights of a previous layer, and YL denotes the vector output of previous layer and this bias. So weights and biases will be generated by the previous layers. So YIL plus 1 is the output of this function of a ZI. So you can just understand this by seeing this figure. So in order to generate a ZL, we need to have a previous layers. So YI is the output of a previous layer which has been just multiplied with the weight, and it has been added with the biases of a previous layer in order to generate a ZI. And next one is we are going to apply any of the activation functions. It can be an sigmoid activation function or ReLU activation functions. After applying this activation function, we are going to obtain YI. In order to understand what is sigmoid and what is ReLU, you can watch this respective video. So this is all about a standard networks. So now we are going to tell you about what is this dropout network for your feed forward or a standard networks. So the figure is going to tell you how to design a dropout network for networks. So these are all the equations. So the extra term here is Rj. So R stands for random probability. So the name itself says that randomly picking some of the layers and we are going to drop those layers. So this R is going to hold the random probability. So this is a function which is going to give you a random probabilities. So the next one is Y. It is just multiply with a random probability with the output of a previous one. So Zi of your present layer is just a combination of this one. So the one addition to the standard layers is we are going to add the random probability for your weights. So that is what here is happening. So the one addition for this dropout layer is adding the random probability for dropping those networks. So rest remains same. So this Zi L plus 1 is same here and Yi is also same. We are going to apply a activation function, and this activation function is a ReLU, 1 divided by 1 plus e raised to minus x. So that is what which have been shown in this respective diagram. In order to generate a Zi, it is a combination of addition of this Yi and biases. So how this Yi is generated? You are going to just multiply this random probability with a Y3. So it is a output of a previous layer. So after having addition of all these layers, we are obtaining a Zi, and the next procedure remains same. We are applying a ReLU function here in order to obtain the output. So this is the main concept. We are introducing this random probability, or this paper is saying that by introducing a random probability, we can enhance the efficiency. So the random probability will be just multiplied with the previous output, and all the outputs are added in order to obtain the respective results, and by applying activation function, you are obtaining the end results. So this is all about how you are going to apply a dropout layer and how to increase this respective the efficiency of the neural networks. So let us see what is this backward propagation. So this backward propagation is a method which is used to update the weights. So how the weights are going to be updated for every image in a training data set for each layers. So for each layers, the loss functions are going to be calculated. So for these layers, one loss function will be calculated. For these layers, another loss function will be calculated. And for the first one, the another loss function will be calculated. So the back propagation actually says that once the single image of a training set is going to be completed, so all the loss functions of all the are going to be updated at once. All these loss functions of all the layers will be updated at a stretch. So that is called as a back propagation. So let us discuss about what are all the experimental results. So these are all the data set they are being used with MNIST. It is a handwritten digit identification, cipher 10, cipher 100. So these are all some of the data set which they are being used in this respective figure. And this is the dimensions of it. So MNIST, they have been used SVM, and they have been made use of a dropout neural networks with a maximum normalization. So these are the methods they have been just done with, and this is the error rate they have been just obtained. So after having all these changes, the final error rate is 0.94. It is almost equal to 99%. So this is in one type of data set. In the similar manner, they have been made calculations for street view house numbers. So in order to identify the house numbers, they have been taken a 32 cross 32 color image, and they have been applied for a convolution network, and it is two fully connected hidden layers. So all hidden layers will be followed by reloads, and this is the error rate which have been obtained for them. Initially they have been done this function, this one, and they have been came up with a final function called as a max pooling and dropping out of all the layers. So it has been achieved 2.55. So max pooling is, we are going to calculate the maximum number in 3 cross 3 matrix. So we can occupy 3 cross 3, 5 cross 5, anything is feasible. Preferably we are going for a 3 cross 3 matrix. In 3 cross 3 matrix, which is the maximum number, so that have been just propagated to the next layer. So by making use of all those layers or functions, they have been achieved a error rate of 2.55. You can just see here from 36 to it has been reduced to 2.55 by including all this maximum pooling, dropout layers and all. So the next one is cipher 100 and cipher 10. So this number tells that the end results will be having these many categories. If it is cipher 10, it is going to provide you 10 different decisions. If it is a cipher 100, so the neural network is capable of providing 100 different decisions. So these are all the error rates which have been just obtained for making use of some sorts of a dropout thing or some sorts of other algorithms which have been implied. So before applying a dropout, the error was 14.98. So after introducing a dropout for whole network, it has been reduced to 14.32, and later they have been adding this dropout for each layers. So by adding this dropout for each layers, it has been considerably reduced from 14 to 12. 2% have been reduced by adding droplets every layers for every hidden layers. Later they have been introduced a reloop. So after introducing a reloop, the error rate of introducing a reloop, the error rate was 11.68. Initially it was 14. So like this, they are going to apply some of the algorithms to reduce the error rate. So this is the street view number they have been identified, and this is a cipher. So 100 different categories. It can be car, it can be animal. So 100 different categories or 10 different categories based on the data set what you have been just obtained with. So these are the different algorithms or different data set they have been just applied for their respective algorithms in order to obtain the results. So let us tell you of a dropout rate. So this is based on the testing errors, and these are all the training errors. And this is the things which have been just compared for an MNIST data set. So let me discuss about this effect of a dataset size. So here, if the dataset size is considerably less, consider it as an 100 or 500, this dropout doesn't works. So here you can just see here, if it doesn't make any of the improvements they have been mentioned here, if the data set is having a 100 to 500 or something like this. So if you are having a larger data sets, you can have a improvements. If the data set is very much lesser, you can just see here. So the data set 10 raised to 2, the error rate was 25. If the data set have been increased 10 raised to 3, the error rate have been considerably reduced from 25 to around 12%. You can just see this graph. If you are go on increasing the number of samples, that is the number of training data set, you can considerably increase the efficiency of your system by making use of a dropout. You can just compare this. Blue color is a with dropout and red is a without dropout. So these are all the effects of having a lesser data set. So that's it for this video, guys. Hope you got a effective information by observing these kinds of a paper. If you are having these kinds of information, and jumping to an machine learning will considerably provide you lesser effects in understanding the algorithms. Thanks for watching. So this channel provides you information about machine learning, basics of a deep learning, C programming in LPC 1768. It is a ARM microcontroller. Interested with these kinds of stuff, please do press the subscribe button. Thank you for watching. Give thumbs up for this video, and important thing is, if you find this video helpful for your friend, do share them. Thank you.